Hello everyone, welcome to the next video of the playlist Placement Interview Questions on Data Structure. I am RVD and a very warm welcome to all of you. If you have not subscribed my channel yet, then do subscribe. You can see the subscribe button right down there. Okay, so that you'll be able to get the alert for my new videos. So let's move on to the next question in this series of data structure. So the question for this video is how to implement stack using queues. Now obviously the concept is you only have the queues and the corresponding operations of queues with you, and we have to implement stack using those operations. Fine. So let's see the basic concept behind it, and maybe we'll even try to look at the algorithm or a pseudo code for the same. So the operations on stack, as all of us know, are push, pop, and stacktop. So these are the operations which we have to implement. But understand one thing, that we don't have the freedom of implementing it directly. But what we have with us is the operations on queues, that is insert and delete. All of you know queue works with first in first out manner. So these insert and delete operations are going to follow the first in first out manner and the corresponding rules. So using these operations, we are going to understand how to implement this concept. So let's see, how do we go for stack using queues? We have only queues with us and we have to implement stack operations. Fine. So we can use two queues, one queue obviously which will act as a stack, and the other queue can be the auxiliary queue. Maybe let us name them as Q1 and Q2. So Q1 will be my queue which will be working as a stack, and Q2 will be an auxiliary queue which will help us in doing these operations. Fine. So let us understand the concept. So let us start with the push operation, and we'll see how exactly we will be able to get the push operation implemented with the help of these queues. Fine. So as I said, we will be having two queues, Q1, Q2 and ELE. This Q1 is going to work like a stack and Q2 is going to be like a auxiliary queue. Fine. Remember one thing, my Q1, even though we are implementing it as a stack, it is actually a queue. So whenever we'll do insert or delete, we have to follow first in first out, but the overall effect of push should be last in first out. Fine. So let's see. So now the idea behind this is, in case of push, it's going to be very easy because my queue insert operation is done at the rear end. So if I visualize this queue as a stack, the insert operation will obviously be same, or rather will be applicable for push directly. So you can see insert, I will use Q1 because that is the one which is acting as a stack, and I'll simply insert ELE in that Q1. That's it. Okay, let's see the effect of that. So if this is the current status of the queue, I want to push one element on Q1. Now see, if it is a queue element, the first element inserted is 10, the next one inserted is 20. Now even if I want to consider this as a stack, the next element I'll be pushing would be, let's say 30. It can be directly pushed using the insert operation. So this is how rather it looks like after you perform push on this particular queue. Q2 I have just drawn here. You can see in this push operation my Q2 is not getting used. Fine. Let's go ahead and try to think about pop. Again, we have got Q1, Q2, and the return type, all of you know, is integer. So the idea is we have to pop from Q1. So if you remember 10, 20, 30, as we've just now seen, the element which is inserted first is 10, then 20, and then 30. So if at all now I apply delete directly, it's going to delete 10. But as per the concept of stack, the element which is inserted last should be popped out or should be deleted first. And hence we have to apply the logic of second auxiliary queue. So you know what I'll be doing? 10, 20, 30. When I'll do delete 10, I'll be putting that in another queue, inserting in another queue. 20, put it in the other queue. 30, when I delete 30, I will realize that my current queue, Q1, has become empty. So the element that I just now deleted is the last element, which obviously will be stored back as ELE for returning as a popped element. Now the elements which are being held by Q2 should also be kept back in Q1. So that will be the second part of the logic. Fine. So let's see step by step. So as I said, while true, it will be infinite loop. So I'll be popping from Q1, or I'll say deleting from Q1, and deleted element which is being kept in temp. How do we use that will be decided by this particular if statement. Whether after deleting from Q1, is my Q1 is becoming empty or not. If is empty of Q1 is not equal to true, that means Q1 has not become empty. So this temp is not the last element. So I can very well insert that in Q2. But after deleting, if Q1 is becoming empty, then my temp was the last element. So I will break. Now obviously, how do I break? I'll come out of the loop by saying go to step 7. So you can see this particular while loop. It deletes the element from let's say Q1. If that element is the last one, then it stops. If it is not the last one, then that element is inserted in Q2. Fine. And once it comes out, you know that temp element is the last element, which is supposed to be the popped element which you are going to return. So currently it is being kept in ELE. Fine. So let's see first how this much part works, and then we will go ahead with the second half. So this is the initial queue. Now if you see Q1, if I want to perform pop, then as per the logic of stack, 30 should be popped. But you know, delete is going to give you 10. Okay. So let's see how this particular code works. While true, delete from Q1. So we got 10. Is my Q1 empty? No. So insert that in Q2. Perfect. Delete from Q1. I got 20. Is my Q1 empty? No. So 20 will be still inserted in Q2. Delete again from Q1. The while loop is going on. After that I got 30 and my Q1 is empty. So you will come out of the while loop, and as per the last step, the temp will be stored in ELE. Fine, let's see the second half. As I already said, second half would be, you have to put everything from Q2 back to Q1. So while my Q2 is not empty, you will delete and you will insert. Once you're done with it, you can return ELE as a popped element. So see the second part. While is empty, Q2 is not true. So while Q2 is not empty, okay, you will delete from Q2, and obviously you're going to put it in Q1. Fine, and that will be continued. Finally, when you come out, you can return ELE as the popped element. So let's see how it works here. So now I'll delete from Q2. I got 10. Okay. Now once you got 10, you would obviously be inserting that in what? Q1. Perfect. Still my Q2 is not empty, so delete. I got 20. That will also be inserted, and now you can see Q2 got empty. So you're going to come out of the while loop, and then the ELE which was being stored as 30 will be returned as a popped element. Fine. So if you have understood, we had designed pop with the help of queues, okay, and the corresponding operations. Fine. Now let us think about the stacktop. Now if you have understood pop well, you know, stacktop is going to do exactly same, except, you know, when last 30 when we just kept that last element temp in ELE, and then we started putting elements from Q2 back in Q1. The only change we will be having in stacktop, after we delete the last element, we break, and when we store that element in ELE, we will be also inserting that element in Q2, because remember in stacktop we don't want the element to get popped. So what will happen is, along with 10 and 20, 30, a copy will be stored in ELE for returning, and it will also be inserted in Q2, so that while placing the elements back in Q1, 30 will also be placed, and 30 is not getting popped from the your queue or so-called stack. So you can see stacktop, you can see exactly same, only the extra step which we need to do I have just marked in red so you people understand. After I keep my temp in ELE, in my pop I don't keep that ELE back or temp back, it's one and the same in Q2, but in stacktop I have to. So I'm making it sure that the element is not getting popped. Fine. So likewise we can have push, we can have pop, and we can have stacktop. So these are the stack functions we have implemented with the help of queue operations. Fine. So I hope all of you understood that this is how we'll be able to implement stack with the help of queues. We will need two queues, one which is getting implemented as a stack, and the other one is a auxiliary queue. Fine. So likewise, I'll obviously come up with more questions, placement interview questions, which I will try explaining in simplified manner, so that you'll be able to get it clearly and you'll be able to prepare all those questions very well. Fine, so that's it for this particular video. Thank you and happy learning.